Atreya Majumdar, and I am a second year student of Electronics and Communication at the National Institute of Technology, Karnataka, Surat. Before we start the session on convolutional neural networks, I'd just like to introduce myself to you. So, I have a few hobbies that I'd like to talk about. The first one is the guitar. I absolutely love playing the guitar. I have been doing so for the past 5 years. It did go on hiatus for like a couple of years in the middle, but now I'm trying to pick it back up during the lockdown. Along with that, I am also a voracious book reader. Uh, I mostly read in the genres of like fantasy, mostly adventure thrillers, fantasies, etc. The Lord of the Rings is right now my all-time favorite series. I also absolutely love watching thriller adventure movies. By now, you might have guessed that this is more of like this genre is more of my thing. Um, yeah, so I absolutely love the DC and Marvel superhero movies as well. One quirk, one weird slash kind of funny quirk that I have is that whenever I'm in a new area, be it a new city, a new country, a town, a village, anywhere, whenever I see a shop's signboard, I will always read out the name out loud. I do not know why I do this. I do not know where I picked up the habit from, but I always end up doing it anyway. Okay, so let's move on to the session now. What is a CNN? What is a convolutional neural network? CNNs are regularized versions of MLPs. Now, an MLP means a multi-layer perceptron, which is just a fancy way of saying artificial neural network. So the design of CNNs is basically based on the workings of the neurons of the animal visual cortex. So it basically mimics how an animal sees and recognizes different visuals. So before we go into how CNNs work, we will try to understand how a computer sees images. So a computer sees images as matrices. Now, if your image is grayscale, the matrix has the dimensions of width and height. However, if the image is colored and it is, let's say, in RGB, then a separate dimension is added for the channels. Thus, the new dimensions are width, comma height, comma 3, since there are three channels, R, G, and B. So the pixels in an image have values between 0 and 255, which is basically the intensity of that particular pixel. So now we come to how do CNNs work? What is the purpose of a CNN? So the idea is that you will give the computer an array of numbers, and the computer will output numbers that describe the probability of the image belonging to a certain class. For example, an image has 80% probability of being a cat, 15% probability of being a dog, etc. So when humans look at a picture of a dog, we can classify it as such if the picture has identifiable features such as paws, forelegs, uh, ears, its facial structure, etc. In a very similar way, the computer is able to perform image classification by looking for low-level features such as edges and curves, and then joining them up and building them into more abstract concepts in deeper convolutional layers. The computer uses low-level features basically, which are obtained at the initial shallower layers of the convolutional neural network to generate higher-level features such as paws or eyes to identify the object in the picture. So that is how CNNs work. And now we come to the architecture of a classic convolutional neural network. So the first and foremost and the most important part of a CNN is the convolutional layer. So what is the convolutional layer? It is basically like a window. It is a smaller matrix than the image, and it goes over the entire image and extracts features by performing convolution on the area that it is covering in the image. So how the convolutional window moves over the image is defined by the stride of the layer. So the stride is basically defined as the number of pixel shifts of the input matrix, which means if my stride is equal to 5, after performing convolution on the current area, the convolutional window we will move over 5 units, 5 pixels, and then start performing the next convolution operation. This basically ensures that our computational expenses go down and training is faster. So next we move on to padding. We usually pad an image in order to ensure that the output after convolution is the same as the input is that the size of the image of output image after convolution is the same as the size of the input image before convolution, and this is done by padding with zeros. So next we come to pooling layer. So what does a pooling layer do? Basically, pooling reduces the number of parameters when the images are too large or heavy, especially since nowadays our images are extremely high resolution, such as 1080p images. So spatial pooling basically reduces dimensionality of the feature map while retaining all the previously important information. So there are three types of spatial pooling: min pooling, max pooling, and average pooling. So currently in the industry, the standard is to use max pooling. So what is max pooling? It's basically taking the largest element from each iteration of the rectified feature map. So as you can see in the diagram, after pooling, we come to the fully connected layer. Now, actually, usually it is grouped along with the fully connected layer, but there is another layer called the flattening layer. So in the flattening layer, we basically take the output from the final pooling or convolution layer, whatever is last before the fully connected layer. We take the output and then make it into an n comma 1 dimensional array, and that is basically called flattening, and this is done so that the fully connected layer can work faster and output its class identities pretty accurately. So how does a fully connected layer work? So after we feed in the flattened output, in the fully connected layers, we basically just combine the features together to create a model. Now, depending on the type of classification, for example, if you use multi-class classification, we use the softmax activation, which tells us what is the probability for each type of class. For example, 50% for a cat, 30% for a dog, 20% for a bird, etc. Otherwise, if our classification type is binary, like it's either 0 or 1, like if it's a dog or not, then we use a sigmoid activation function. So now we just come to applications. So CNNs have myriad applications, and the most important is in computer vision, especially in the field of object detection. The most sophisticated object detection algorithm right now, which is you only look once, or YOLO, which is the abbreviation. This uses a more advanced form of CNNs called faster RCNNs, which is basically fast computed region-based convolutional neural networks. So next, we come to security. Now, in security, obviously, a very, very new and upcoming security metric is facial recognition, which can be found in most mid to higher range mobile devices. Now, facial recognition is also done by using CNNs. It uses a particular type of training called one-shot learning. Then next is geospatial applications, and finally we have optical character recognition, which is an extremely important and widely industry used tool. So let's say I have I have a picture of a PDF of 100 pages. So obviously I don't want to write the entire thing down by hand. It'll take too much time and it's just tedious work. So what I can do is feed the pictures into an optical character recognition program, and all the text will be extracted from the images. So these are the main applications of convolutional neural networks. So in order to get started in the field, these are some easy references. So the best resource at the moment is the Convolutional Neural Networks course on Coursera by deeplearning.ai, and it is directly taught by Andrew Ng himself, who is a foremost authority on artificial intelligence and machine learning. There are also other resources such as TensorFlow, which have their own tutorials on machine learning, deep learning, etc. So thank you, and I hope you were able to understand the basics of convolutional neural networks.
Thanks for watching. Subscribe and click on the bell button as to not miss out any content. Contact us here.